Hello everyone, I'm Kang Liu. I'm from the Institute of Automation, Chinese Academy of Science. It's my pleasure to be here to present our work. This talk is about the handling coding style problem in reduced spam detection by jointly embedding text and behaviors. This work is a joint work with Xue Wang and Jun Zhang. Okay. As we all know, reviews are very important for the online seller and manufacturers. Existing studies have shown that actual half-star rating on the Yelp.com could cause the restaurant to sell out 19% point more frequently. And one star increase in rating will lead to 5 to 9% increase in the profit. So reviews are really important. However, according to the BBC report, 25% of reviews on Yelp.com are fake. So it's very urgent for us to detect such fake reviews. Previous studies always regarded this task as a task of classification. So the most efforts has focused on how to extract effective features to indicate effective reviews. So previous method always select increased features to detect effective reviews. However, the experienced spammers who could write fake reviews with some hidden motivation, they try to hide them very well. So the writing reviews will look like rather truthful. So it's very difficult to detect user reviews by only use text features. So many researchers have focused on the behavioral features. The assumption that a spammer, if a user is a spammer, the review they write may be fake reviews. For example, such behavioral features looks like if the reviewer posts several reviews on different products in a short period, the behavior will be a spammer, and the reviews that he writes may be a fake review. So, however, such method has faced the coding style problem. In previous method, research had to take a long time to collect the reviews behavior information for extract behavioral features. It usually takes several months to count the difference of time stamped between the last and the first reviews for a review. In this way, when they got effect behavioral features finally, some major damage might have already been done. So it's very challenging and important to design algorithms that can detect reviews, spam, and so on and possible. Ideally, write just a spammer write the first reviews, the system could detect them up. So this code style problem in review spam detection is to identify fake reviews immediately when a news review posts just one reviews. The traditional method relied upon the user behavior information, but for a new user or reviewers, there's no sufficient behavior of the behaviors for constructing such behavioral features. Here is the experiment combination for different features. The LF means the implicit feature or text features, and BF means the behavioral features. From this result, the BF rich means the behavior feature based on the rich behavior information. From this combination, we can see if we could construct a behavioral feature based on the bounding behavior user behaviors, we could obtain better results. So we have the challenge the code style review spam detection. The first challenge is how to extract behavior features for a new user. Just such a new user just post a review. And the second challenge is how to learn behavioral features pure method always manually design some features, but for the different domains, we try to find a way to learn the behavioral features automatically. So for this purpose, we construct a data site and based on the YAP data site. The left table shows the static information on the YAP data site, and the right table shows the data site we construct based on the YAP data site. We connect, we select the user from October in 2004 and to the January in 2012, and use the reviews and the training data. For the hotel domain, we obtained the 1,132 reviews in the training site, and for the restaurant domain, we have the 14,012 reviews in the training site. And we randomly select a part of reviews who post new reviews after January in 2012. It means that this user is a new registered user, and select their first reviews to build our tested data site. So for the coolest problem in open spam detection, we have the basic observation. Reviews individual characterized such as background information, motivation, and interactive behavior style have a great influence on the review's text and behavioral information. For example, we can say the college student, if a college student moves to a new place, they always select the Yoast hostel, and the reviews is talk about the room price and the financial analysts. If they always select the business hotel, and the reviews is always talk about the service. So this observation tells us that the text information and behavior information of the review are correlated with each other. Based on this basic observation, we just have this basic idea just to employ behavior information of the existing similar reviews to a new reviewer to approximate his behavior features. For a new reviewer, we compute the textual similarity between the citizen and the extended reviewer. If we found the text information which is similar to that of the new reviewer from the extended reviews, and then we employ the behavior information which is related with from the text information to approximate the behavior information of the new reviews. So we propose a neural network model to jointly encode the text and behavior information into the review embeddings for detecting the review spam in the code star problem. So when a new reviewer posts reviews, the model can replace the review with the similar text information and the correlated behavior information encoded in word embeddings. So in the online website, we have the three kind of nodes. The first node is products such as the hotel or restaurant, and the second is the user, and the third is the reviews. So in this graph, we try to use the graph embedding methods such as the transfer model to learn the product embeddings, user embeddings, and review embeddings. The basic idea is we think the product embeddings plus user embeddings should equal to the review embeddings. For the review embeddings, we use the convolutional neural network to learn the semantic interpretation of the text. Especially, we use the review rating to construct our CNN model to make the reviews with the similar rating will be similar. So we have the two object function. The first is to construct the product, to model the relation between the product, review, and the text. And the second objective function is to model the text and reading. So we use a linear model to combine these objects together. Here is the experiment result. The first we compared our method with the traditional features. The LF means we use Mukherjee in 2013. We use the background as text features. And the BF, we use behavior features in 2013. And ours RE means we use the learned review embeddings by our model. And ours RE plus RE and PRE means we use the learned review embeddings by our model and product embeddings and the reading embeddings. From the result, we can see our method outperformed the previous method. And the second experiment, we set some baselines like ours. The BF IDC plus F means we found the most similar expected reviews by ID distance and take the found reviews, reviewer behavior feature and approximated behavior features for a new review. And the second baseline means we found the most similar existing reviews by average pre-trained word embeddings. We just use the word vector or toolkit to learn the word embeddings. From the result, we can see our model is better than these two baselines. It means we use the transit model to construct the relation between the product and the user and the text. And the last experiment, we want to prove the effectiveness of the encoded human information. The left method means ours CNN. We just use the static CNN model to learn the text embeddings. The right method means the full model. From the result, we can see our method is better than CNN model. It means I think it's because that we just use unsupervised product and review relation into the CNN model. Okay, the last slide is our conclusion. This work explores the post-start problem in review spam detection. We try to prove the traditional liquidity and behavior feature are not effective enough in this task. And we propose a neural network model to jointly encode the text and behavior feature into a review embeddings for the post-start spam detection task. And our experiment proved our method. Okay, that's all. Thank you. I think this method could be the transfer to the algorithm. You could in the sort of website to find the relation between the user and you can use the graph embedding method to construct the embedding of the user. So you can use the behaviors to indicate some blocks or some smart.
Any other questions? Another question. You did it for English, right?
Yeah.
Is it easily extendable to other languages?
I don't extend it to other languages. The behind reason is the construct such data is different to collect. So I just to collect the data and that is open accessible data. So I just perform experiment on the English. But I think this method always works for other languages, because it's an integrated